Yeah, yeah, I can hear you now. So, how are you? Yeah, I'm doing great. So, what chapter is currently going on right now? Uh, that work energy power? Or is that work energy power the chapter? Okay, yeah, earlier we were discussing about Newton's laws, right? Yeah, Monet. So, do you have any questions to discuss? Okay, 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 no issues. Then we'll do these problems. Yeah. Yeah, sure, sure. Or you can even share the screen or the image of the question. That would be more appropriate, I guess. You can send me the image of the questions. Do you have a soft copy of questions? Do you have soft copy of questions? Okay, 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 okay. You can share your screen and show me the questions. That would be fine, I guess. There is an option called share screen at the bottom of the meeting. Nearby chat and then share screen, record reactions. Yeah, did you find it? Cool. 31. Let me get a screenshot of these questions. Right. So that, and 31 and 31, 33. Let's get screenshot. And then 35. Yeah. Any other questions else? 36 and lastly 40. Okay. Yeah, sure. Yeah, I guess I'm done with this part. Now let's move on to the second one, part B. Okay. Yeah, it's all settled. Mm-hmm. So let's start with 31. I guess now you can stop sharing your screen so that I can share my screen. Okay, now let me share. Hello. Monet, are you there? Yeah, yeah. Are you able to hear me? Okay, cool. Now you can see the screen, right? Okay, now let's start with 31st. Question number 31 says that a 5 kg box on a horizontal table is pushed by a horizontal force of 50 Newton to the right, and if the coefficient of friction is 0.4, show that it's not possible for the box to move, right? So, Monet, tell me what's the mass of the block? 5 kilograms. And coefficient of friction 0.4. And now we need to show that. And what is the applied force? It's 15 and to the right, and we need to show that the block is not going to move by applying the force of 15 Newton, right? Okay, Monet, first of all, the most important thing that we need to understand before solving this question is that the frictional force is a self-adjusting force. Yeah, frictional force is a self-adjusting force. So let me write it, adjusting force. It means that, let's say, and also the maximum frictional force is given by mu times mass times g, or it can be also written as mu times n. Now tell me what is the maximum frictional force the block can offer. Let's just substitute these values. The mu value is going to be 0.4 and mass is 5, and let's consider g to be 10. uh, what would be this value? Yeah, exactly. So it's going to be 20 Newton. So that means the frictional force in this case, the maximum frictional force it can offer is 20 Newton. So until and up till you are applying the force below 20 Newton, the block is not going to move. Because let's say if I apply 1 Newton force in this 5 kg block, now frictional force is going to act with 1 Newton in opposite direction to stop moving. And if I apply 3 Newton, now the frictional force is going to be 3 Newton. And this is the reason why which I'm calling the frictional force as a self-adjusting force, because yeah, see, uh, what happened? Okay, okay. What I'm saying is that whatever the force we are applying, the frictional force is also adjusting. If I apply 3 Newton of force, then the frictional force is going to be 3 Newton. If I apply 5 Newton, then frictional force is going to be 5 Newton to oppose the 5 Newton. Now let's say if I apply 20 Newton, now the frictional force is going to be 20 Newton. Now what if I apply 30 Newton force? Then what is the frictional force acting on this block? Pardon? It's not 10, it's 20 Newton. Because the maximum frictional force the block can offer is 20. Until and up till you apply the force below 20 Newton, it's going to self adjust, and it's going to get the same value as the applied force. Let's say if I am applying 3 Newton, the frictional force is going to be 3 Newton. If I apply 5 Newton, the frictional force is going to be 5 Newton. But if I apply 30 Newton, or the force above 20 Newton, then frictional force is going to be just 20 Newton itself. Yeah, is this clear? Now shall we move on to the next one? Let me clear these drawings. And So 33, right? Okay, the 33 question says that a wooden pallet carrying 600 kg. Not able to see the question properly. Yeah, 600 kgs rest on a wooden floor. A forklift driver decides to push it without lifting it. The coefficient of static friction of wood on wood is 0.28. The coefficient of kinetic friction on wood is 0.17. Show that the force that must be applied to just barely get the pallet moving is 1680 Newton. Okay. So tell me what's happening here. Hmm. Okay, there is a wooden pallet of mass 600 kilogram. Yeah, but he gave us two types of coefficient of frictions, right? He has given two types of coefficient of friction. Yeah, exactly. One is static friction, which is 0.8, and what is the kinetic friction? 0.17. It's too less. But static is 0.28, right? It's not 0.8, it's 0.28. It's 0.28 and 0.17. Now, what the first question he wants to know? Hmm. Now, how do we find the maximum static frictional force that it can offer? We just now discussed that. How do we find the maximum frictional force acting on the block? How to find the maximum frictional force? No, I want the maximum static friction. We just now discussed the formula. It's mu times mass times acceleration due to gravity, right? 0.28. Since I'm calling it as maximum static friction, I just want maximum static. Static means the word itself says when the block is at rest, it is said to be static. So until and up till the block is not moving, the force with the frictional the static friction is going to act. But once the block starts moving, the kinetic friction starts acting. Is this clear? Yeah. See, the idea is simple. See, we already discussed that if there is a force which is less than the maximum force the block can offer, then the frictional force is going to adjust to the applied force. Let's say 3 Newton. If I apply 3 Newton, the frictional force is also going to be 3 Newton. Just we discussed in previous question. But what if I apply the more force than the maximum force the block can offer? Then the block is going to start moving. Once the block starts moving, the kinetic friction is going to act. Static friction is no more. It's going to disappear. Yeah. So tell me, what's the maximum static frictional force? It's mu times mass 600 times 10. And what's this value? It's 28 times 6 times 10. And I just 1628 times 6. Yeah, 1680. So it means that until and up till I apply the force 1680 Newton, the block is not going to move. If I apply a small force greater than 1680 Newton, then the block will start moving. Is this clear?
Yes, sir.
Okay, now let's move on to the second part, and what the second part says.
After a bit of time, the pallet begins to slide.
Mm-hmm.
Note that the pallet moving after sliding under the same force we calculated in the previous part will be moving at 0.55 miles a second after half a step.
Will be moving at a speed of 0.55 meter per second after half a second. Hmm, interesting. So let's get back to our problem. So the mass is 600, right? This is 600, and what is the amount of force that we are applying?
Um, 16 or 18 newtons.
16, 18 newtons, and what's the coefficient of kinetic friction?
0.28.
Oh no, I want coefficient of kinetic friction, not a static friction.
0.17.
Okay, 0.17. Now what is the value of kinetic friction? It's coefficient of kinetic friction. It's not a force due to kinetic friction. Both are different. I want the force due to kinetic friction.
Um,
The formula is same. It's mu times mass times g. Whenever you want to calculate the force due to friction, either it is kinetic or static, we use mu times mass times g, where g is acceleration due to gravity.
okay.
And this is 0.17, and the mass is 600, and g is 10, and what's this value?
1020.
1020. Okay, so in this case the frictional force acting on the block is 1020 newton towards left. Is it clear?
Yes, sir.
Now what's the net force acting on the block?
The net force is 1,680 newtons.
Hmm. And you see, on block 1680 newton is applied by an external force, but frictional force is also acting on the block towards left with the 1020 newton, and these two are acting in opposite direction. So what would be the net force, resultant force?
Can you say that again, please?
See, basically the idea is that I'm applying 1680 newton towards right side. Are you following, Monet?
Yes, sir.
And 1020 newton is acting towards left side. Now what would be the resultant force, or what would be the net force?
So subtract it.
Yeah, exactly, because these two are acting in opposite direction, so we just need to subtract. So this is the total force, and it's what's the value it's going to turn out?
660.
660. Yeah, this is 660 newton. Now this is the force acting on this block. Now what is the acceleration of the block?
It says that we have to prove that it's 0.55.
That is the velocity after a half second, but first of all, to find the velocity after a half second, we need to find the acceleration first of all.
Okay.
But what is the acceleration? We already discussed in our previous session. How do we find acceleration? Once you know the net force and the mass, then how do we calculate the acceleration?
I'm not sure.
Yeah, that's Newton's second law. Force equals mass times acceleration. So
Oh, okay.
yeah, you remember this?
Yes, sir.
So let's substitute these values. Force is 660 newton, and mass is 600, and what's its value? It's going to be 611 times 610 times. This is meter per second.
Okay.
Sorry, this is meter per second square, because acceleration has got units of meter per second square. So this is clear up till this point, right?
Yes, sir.
Now we need to find the velocity after half second, right? So velocity after some time t is given by v equals u plus at. Are you familiar with this formula?
Yes, sir.
So let's substitute. Initially it is at rest, so u is 0, plus acceleration is 11 upon 10, we just now found out. And what's the time? Time is half second. Let's just substitute this. So how much we are going to get? It's going to be like 11 upon 20,
Okay.
2 tens to 5.5, and it's going to be 0.55 meter per second. Yeah, is this clear? Do you have any doubts in this problem?
No, sir. It's clear.
Okay, now let's shall we move on to the third one, third part?
Yes. Okay. So it says, show that if the forklift stops pushing, the pallet slides a distance of 0.089 meters before coming to a stop.
So that okay, now he's saying that this force is not going to present, and we need to find the forklift stops pushing, the pallet slides a distance of 0.89 meters before coming to stop, right?
Yes, sir.
Okay. uh, See, for this, if there is no forklift, let's say there is no external force, now what would be its acceleration in this case?
Like 0.55 meter per second squared.
This is velocity, this is not acceleration. This is a velocity after half second, that's what we just found.
Okay. Yeah. So 0.89 squared.
Yeah, but this is the acceleration when there is also force of 1680 newton, but this force is not it's not present, because we stopped applying external force. So the only force acting on this block would be frictional force 1020 newton, and its mass is 600. So its acceleration would be force upon mass 600 upon 1020.
Okay.
So if this is the acceleration, now we need to find the distance travel, right?
Yes.
So that's very simple. We know that v square minus u square equals to 2as. Are you familiar with this formula?
No, sir.
This there are three equations. Let me write for you. Actually, I'm not able to clear. So basically, there are three kinematic equations. So first one is s equals to ut plus half at square, and then v equals to u plus at, and then v square minus u square equals to 2as. In all these formulas, s is the distance traveled, and v is the final velocity, and u is the initial velocity.
I think that's where I might be confused. These different values are
Yeah.
initial velocity.
Okay, what do you guys use for initial velocity?
Initial velocity is vi.
Okay, yeah, that's also cool. You can even write it as vi and vf, and a is the acceleration.
Yeah, and then distance is d.
Yeah, distance is d. Okay, So then our formula would be Vf whole square minus Vi square equals to 2AD. So once the block stops, its final velocity would be. Are you there, Monet? Hello.
Hello?
Yeah. I'm not able to hear you.
Oh, when it stops, it'll be 0
Yeah,
point.
exactly. If it stops, its velocity is going to be 0, and its initial velocity is given as 0.55, and its acceleration, we just now figured it out, 600 upon 1020, and you just need to find the value of d. You can just substitute these values and get this value as a homework, or you can do it later, I guess. It's just a calculation part.
What did you say the acceleration was?
Acceleration was 600 upon 1020.
Okay.
So you just substitute all these values. So finally, d would be, let's write d. It turns out to be 0.55 square upon 2 times 600 upon 1020. So this would be your final answer. So please check the calculation, and until then we'll move on to the next question.
Okay. Why is it 0.55 squared?
Because its velocity is 0.55 meter per second after a half second, because its initial velocity is 0.55 meter per second, which we just now showed.
Okay.
So is this clear regarding the whole problem, so that I'm going to clear. Shall we move on to the next question, Monet?
Yes, sir.
Okay, I'm clearing all these drawings. Okay then. mm. So you didn't go to school?
What did you say?
You didn't go to school while this lecture?
Yes, I was in at school this day.
Okay, but you missed it.
Yes, I did miss it.
Okay, no issues. So Braden, right now you are, sorry, Monet, you are doing high school right now.
Yes, sir.
Okay, cool. So how is your studies going on?
Good in every other class except this one.
Except physics.
Yeah.
But physics is a most interesting subject, I guess. The only thing is we need a right person to teach.
Okay.
Okay, now let's move on to the next one. So next question is.
A boy a boy slides a flat stone across a surface. The
Mm-hmm.
stone has a mass of 0.1 kilograms
Mm-hmm.
and its coefficient of friction between the stone and the ice is 0.1.
Mm-hmm.
The stone has an initial speed of 8 meters per second.
Mm-hmm.
Check if the stone can travel a distance of 32 meters before it hits the ice.
This is also similar to the previous question, but we'll just do it. I want you to do this. I want you to tell me, you to teach me how to solve this question. So there is a
Okay.
stone, right?
Yes.
And it is placed on some ice. Let's say this is our ice, and this is a stone. And what's the mass of the stone?
0.1 kilogram.
0.1 kilogram. And what's the coefficient of friction?
0.1.
This is also 0.1.
Yes.
Okay, cool. Now tell me, what's the force, frictional, kinetic frictional force?
Um, the coefficient for kinetic friction is 0.1.
Mm-hmm. What's the force then? Force due to kinetic friction, Fk.
Okay. I'm not sure.
But we just now discussed how do we find the force due to friction. I just gave you some formula.
What's the formula again?
It's mu times mass times g. This is a very important formula. So from this, how much we are going to get the force due to kinetic friction?
We would multiply 0.1
Mm-hmm.
um, the mass, which is
Again
0.1
0.1 times
times
10, and
10 to the negative 11
so it turns out to be,
times 0.1.
yeah, this is 0.1 Newton force. Now what is the acceleration of the stone?
Acceleration,
Yeah.
the initial speed is 0. Just 8 miles per second.
Yeah, they also gave us initial speed, right? Vi,
Yes.
and it's 0.8.
Um, just 8.
Is that okay?
No, 8.
It's it's just 8.
Yes.
It's 8 meter per second. Okay, but tell me, what is the acceleration?
It didn't give us acceleration.
But we can find acceleration using our Newton's second law.
Okay. Do you have the equation handy?
Okay, it's this F is equals to mass times acceleration. This is our Newton's second law.
Okay.
So this is from this, how do what would be the acceleration?
It would be 0.1 divided by the mass, which is 0.1.
Okay, this is such a beautiful value. Everything is going to be 1. So acceleration is 1 meter per second square.
Okay.
Now again we need to use our previous formula, final velocity square minus initial velocity square equals 2 times acceleration times distance traveled. Now what's the final velocity?
The final, it gave us the initial speed, which is 8 miles.
Okay, this is 8. This is 8 meter per second square. And what is the final velocity then?
It'll be 0 because it comes to a radius.
Exactly, this would be 0 equals to 2 times, and acceleration is 1. Actually it is negative because the force is acting, frictional force always oppose the motion. Friction always oppose the motion.
Okay.
So we are considering it to be negative, acceleration to be negative, times distance. So this negative is going to get cancelled, and 8 square is 64 equals to 2 times the distance traveled. From here you're going to get d equals to 64 upon 2 meters. And what's this value?
It's 32.
It's 32 meters. Yeah. So this is all about this question.
Okay. Thank you.
Yeah. Now let's move on to the next one.
Okay, the next one is number 36, and it says a 23-kilogram suitcase is
Mm-hmm.
being pulled at constant speed by a handle that
Mm-hmm.
is at an angle at 25 degrees.
Mm-hmm.
The normal force exerted by the floor on the suitcase is 180 newtons.
Mm-hmm.
Show the actual force F applied to the handle is 118.3 newtons.
Okay, so we have got to find the normal force acting, right? So let's do this. Uh, Once again, what's the mass of the block?
23 kilograms.
This is 23 kilograms, and he's saying that he's applying some force at some angle, and let's say this is theta, and the theta value is given by,
25 degrees.
okay, this is 25 degrees. uh, and they also said about normal force, right? What is the normal force acting?
180 newtons.
So normal force is 180 newtons, right? So this is F applied, or I can just say FA. Let's write it as FA, or just F. We need not to write anything else. Now you see the force F can be resolved into two directions. If there is any force, and if the force makes an angle theta along some direction, if this is force F, now the force along this direction is given by F cos theta. So is this clear? Sure. See, if there is a force acting on an object, let's say this is a force acting on an object, let's say this is our object. Now if I want to calculate the force along this direction, and if the force makes an angle theta with this direction, and this is force F, then the component of force along this direction is given by F cos theta.
Okay.
So that means the effect of force along this direction is F cos theta, and along this direction, see, let's say if these two are 90 degrees, these two are perpendicular to each other. If this is horizontal is 25 degrees, and what would be this value theta?
Oh, we're finding the value.
Yeah, I want this angle. This is 90 degrees, and this is theta 25. Then what would be this value?
Can you say that again?
I want to find the value between this vertical line and the force F.
Oh,
This
65.
this is 65. So what is the force along this direction?
The force.
F along this yellow color. If this angle is 65 degrees and this is F, now the force is going to be F cos 65 degrees. Because the force along any direction is F cos theta, here theta is 65 degrees, right?
Yes, sir.
So the force along the upward direction is F cos 65. So this is clear.
Yes, sir.
Now there is also force due to gravity, and what would be its value? What is the force due to gravity?
10 miles per second.
I want force due to gravity. Force due to gravity is mg.
Which would be 23 kilograms.
It would be 23 times 10 newton, right? Because force has got units of newton.
Okay. So
Yeah,
force due to gravity.
yeah. This is a force due to gravity. Now you see, force due to gravity is 230 newton in downward direction, and force due to applied force horizontal component has got F cos 65 in upward direction. So the total resultant force, it would be 230 in downward direction minus F cos 65 in upward direction, because these two are acting in opposite directions. So is this clear? Now let's what's the value and this F net is nothing but normal force, and this is 180. 180 equals 230 minus F cos 65. So from here you will be getting F cos 65 equals to 230 minus 180. And what's this value? 230 minus 180?
165.
165? No.
Well,
I don't even think it's 180. 230 minus 180 is let me check. 230 minus 180, yeah, it's 50.
here, I read the wrong thing.
No problem. So this is 50. So what is the value of F then? F equals to 50 upon cos 65. Now what's the value of cos 65? You can use the calculator and let me check.
0.42.
Okay, 0.422. So let's substitute these values. 50 upon 0.422, and what's the value? 50 upon 0.422. It turns out to be approximately 118.483, right? So is this clear about this question?
Yes, sir.
Now shall I move on to the next one?
1 second. I will close it.
Sure, sure.
37 kilograms.
37. Okay, show that the normal force exerted on a 2.7 kg book resting on a surface incline at 32 degrees above the horizontal as a magnitude of 22.9 Newton. If the angle of incline is reduced, do you expect the normal force to increase, decrease, or stay the same? Right? So let's clear this. So there is an inclined plane, and what is the inclination given? What is this angle inclination theta given?
32 degrees.
This is 32 degrees, and we also do have a block, a book of mass
2.7 kilograms.
2.7 kilograms. So basically the idea is that mg acts always towards the downward direction, so force due to gravity is mg towards in this direction, right?
Yes, sir.
Now what is this angle?
The angle.
Yeah, this angle.
No, I just add on it.
Now basically here it forms a triangle. You can see that this is a right angle triangle, and we know that sum of the angles of a right angle triangle is 180 degrees. So this is 90. If this is 32, then this would be 90 minus 32. So it turns out to be 90 minus 32 is 58. So this angle is 58 degrees. Now let's say this is perpendicular. Let's say this is 90 degrees and this is 58 degrees, and this angle would be
Which angle?
this which I'm doing it with yellow color. This angle.
32.
Yeah, this is 32 because the total angle is 90. This is 58, so this is going to be 32. Now force along this direction is mg, and what's the force due to gravity? Force due to gravity is mass times g, and it's 2.7 times g, so it turns out to be 27 Newton. Now what is the force along this direction? If this is 32, this is 32 degrees, and we just now discussed if there is a force F along any direction, and if we want to find the component of force making an angle theta, then it is given by F cos theta. So here theta is 32 degrees, so therefore the normal force, it would be 27 cos of 32. So can you please do this calculation for me?
Yes, sir. 22.89.
22.89. Okay, this is a very good approximate value of 22.9. So basically, the normal force is a force which is acting perpendicular to the surface. See, this is a perpendicular to this contact. So this is what we call it as a normal force. So this is the most important point. Normal force always acts perpendicular to the point of contact. So in this case, we are getting normal force as 27 cos theta, because 32 is nothing but our inclination. So you see, as the value of theta is increasing, the cos theta value would decrease.
Okay.
So the normal force would decrease.
I see.
So this part is also clear, I guess. Shall we move on to the next one, Monet?
Yes. The next one. Yes, please.
This is our last one. By the way, how do we pronounce your name? Is that Monet?
Monet.
Monet.
Yes.
Okay, fine. So Monet, how to solve this one? So first of all, what the question says, let's read it out. Could you please read it out for me?
Say that again, please.
Could you please read the question for me?
Okay. A 65-kilogram skier speeds down a trail as shown below. The
Okay.
surface is smooth and inclined at an angle of 22 degrees with the horizontal.
Mm-hmm. So we do have a square. Let me just
Do you want me to reset or you can just draw?
give me a minute. I will just draw the thing. So what's this angle? This is 22.
22.
Uh, this is 22 degrees, right?
And a 65-kilogram skier.
Okay, I'm not good at drawing, so don't mind this. And its mass is
65 kilograms.
65 kilograms here. Okay.
As a rectangular trail.
Okay then. Now what's the first part?
Find the direction of the net force on the skier and show that the magnitude of this net force is 243.5 newtons.
Find the direction of the net force on the skier and show that the magnitude of this net force is 243.5 Newton.
Yes.
Okay, the skier is moving along the plane, so he is moving along this direction, right?
Yes.
Now the force of gravity is going to act along this direction. And what's the amount of force due to gravity?
M times gravity,
Yeah,
mm, 650.
650 Newton. And what is this angle?
This angle, is it 22 degrees? Then 68.
Yeah, exactly. This is 68. And what is the force along this direction?
Force along that direction. I'm not sure.
Yeah, see, force mg is acting along this direction, and
Mm-hmm.
this angle is 68 degrees. And what would be the force along this direction?
Oh, so that would be 68.
Mg cos 68, because we just now discussed, right? A force due to any direction is just force times the cos of its angle.
Yeah, I was just thinking because I always mix up sine and cosine.
Okay, but this is very clear. You should always use the cos of angle made with this. So what would be its value? It's 650 times cos of 68. Now let's calculate this value. 650 times cosine of 68, 6.37 times 650. Yeah, 243.494, which is approximately 243.5. It's not a good, it's good approximation, by the way. So yeah, so this is about the first part.
Okay, that's the answer to the first one. So then we go to part B. Does the net force exerted on the sphere increase, decrease, or stay the same as the slope becomes steeper?
we uh, we already, okay, as the slope becomes steeper. What do you mean by steeper means
I
eh,
can explain. That was the last part of the question.
okay, what do you mean by steeper? Steeper means does it mean that angle is increasing or decreasing? This angle is increasing or decreasing?
I guess they're saying that the first angle, the 22-degree angle,
Mm-hmm.
if the hill were to get steeper, as in that angle would increase,
Exactly.
then
So then we need to find the force, right?
yes.
You see, if this is 22, let's say instead of 22, I am calling it as theta. Okay. Now, what would be this angle?
What angle?
This let me mark it with yellow. So this angle, if this is theta, then what would be this angle?
You need you recommend me to know this? I didn't know.
But I know this angle. I know this angle to be theta. Now I want to know this angle.
I'm not sure.
No, you know that because you just now say that if this is 22, this is 68. Then if this is theta, then this would be, it's 90 minus theta, right? Because you just calculate this angle by subtracting 22 from 90. So if I were to say that this angle is theta, this angle would be 90 minus theta.
90 minus theta.
Yeah. See, let me draw this for you. See, this is theta, and this is 90 degrees, and this would be 90 minus theta, because the sum of angles in a right angle triangle should be 180 degrees.
Mm-hmm.
So this should be 90 minus theta. So is this clear?
Yes, sir.
So the force along this direction, it would be mg cos of 90 minus theta. We just now wrote it as 68. 68 can be also written as 90 minus theta. Now what would be this value? Mg cos 90 minus theta can also be written as mg sin theta, because cosine of 90 minus theta is sin theta, right?
Yes.
So
Hello.
hello Mone, am I audible?
Now you are.
Yeah, yeah. So are you following me up until this point?
Can you explain the mg cosine part?
Yeah, yeah. See, here the angle is 90 minus theta, which we just now figured it out. So if angle is 90 minus theta, the force along this direction, this angle is 90 minus theta. So it would be mg cos of 90 minus theta, because force times cos of the angle made with this inclination. We just now figured it out, mg cos of 65, 68. Instead of 68, we are writing it as 90 minus theta.
Oh, okay.
But what is cos of 90, cosine 90 minus theta?
Cosine. What? What are we solving for?
I'm solving for cosine of 90 minus theta. It can also be written as sine theta according to mathematics. So this is a cosine 90 minus theta is sine theta, and similarly sine 90 minus theta is cosine theta. So these are two trigonometric identities. So from this we can get the normal the force acting on the person would be mg sine theta. Now you see, as the value of theta increases, the sine theta also increases. So as the slope gets steeper, the force increases. So is this clear, Monet?
Yes, sir. Thank you.
Okay, okay, bye then. I guess we are done with the session. And do you have any other doubts which you wanna ask?
I think that's it.
Okay, cool. Then we'll meet in the next session. Bye.
Yep. Bye. Thank you.
Thank you.